Welcome to Spring LIB.
The right circular cylinder is inscribed in a sphere of radius r, and we're asked to find the largest possible surface area of such a sphere. So I'll draw a diagram.
Can you please show me your boobies look when you're being almost murdered by podcasts?
So this is the sphere, and the right circular cylinder about here.
But I kind of feel like you can still do it. I kind of feel like
Now the big sphere has a radius of r. Notice that this is the distance from the center of the sphere to the corners here of the cylinder.
You're a good ass poster, man. That shit about how his company was very website or whatever.
Now let's call the height of this cylinder h. And the radius of the cylinder, we'll call this x. And by Pythagorean theorem, we have that h over 2 is equal to the square root of little r squared minus x squared. Now the surface area of a cylinder, I'll call it SA, or maybe just S. This is going to be the areas of the side. This is pi 2 pi x times h plus the area of the circles on the ends, which are 2 pi x squared. We can write this as a function of x by substituting for h. This is equal to s of x is 2 pi x times 2 times the square root of r squared minus x squared plus 2 pi x squared. Now to find the largest possible surface area, we're going to use derivatives. So I'll differentiate. So s prime of x, it's 4 pi times the square root of r squared minus x squared plus 4 pi x times negative x over the square root of r squared minus x squared plus 4 pi x. And we'll solve the equation s prime of x equals 0 to find the critical points. So we have 4 pi times.
Dude, have you ever read a Tom Clancy book? They're so dumb. I played like some. Yeah, it's like he looked at his watch, 1500 o'clock. Nice, he said. He met the other sec brew DevOps guys down at the cafe in Barcelona. 19 million hours, he had to be Beijing.
So this is 4 pi times r squared minus x squared minus 4 pi times x squared all over the square root of r squared minus x squared plus 4 pi x equals 0. Solving for x, well, I have x equals, on one side I have the radical function, negative r squared minus 2x squared over the square root of r squared minus x squared. Now, to solve this, I'll square both sides. We get x squared equals, see, this is r squared minus 2x squared all over r squared minus x squared. Across multiplying, I get x squared times r squared minus x to the fourth, and this is equal to r to the fourth minus 2 times 2 is 4, r squared x squared plus 4x to the fourth. So we get 0 equals r to the fourth minus 5 r squared x squared plus 5x to the fourth. We can write this as a quadratic equation. Five times x squared squared minus 5r squared times x squared plus r to the fourth equals 0. Using quadratic formula, you can find x squared. So x squared is negative b, which is positive 5r squared, plus or minus the square root of b squared, which is 25r to the fourth, minus 4 times a, which is 5, so minus 20 times r to the fourth, all over 2 times 5, which is 10. This is 5r squared plus or minus the square root of 5r to the fourth over 10. This is equal to 5 plus or minus the square root of 5 times r squared over 10. However, we actually have an extraneous solution. If you try to plug in 5 minus root 5 x squared over 10 to the original equation, or to this equation here, it does not work. So we just have that x squared is equal to 5 plus the square root of 5 times r squared over 10. Therefore, we find that x is going to be, and because x is a positive length, this is the positive square root of 5 plus root 5 r squared over 10, which is equal to r times the square root of 5 plus root 5 over 10. Now let's substitute this value of x into our equation for the surface area. So our max surface area is s of the square root, r times the square root of 5 plus root 5 over 10. And there's a lot of algebra to do here, but you should get, this reduces to pi r squared times 1 plus root 5. See if you can find this on your own. Therefore, This is the largest possible surface area of a cylinder inscribed in a sphere of radius r.